Hello and welcome. So in today's class we are starting our third semester syllabus, class 12, first chapter, that is electrostatics. So in electrostatics we have to study the first question arises that what is meant by an electric charge. So if we consider a matter that is made up of elementary particles, that is atom. So atom is made up of, we know that atom is made up of electron, protons and neutrons. So there are some masses of electron, protons and neutrons. So there is a gravitational force acting between them, but when experiments are taken out on them so there exists another force that is different from the gravitational force, and that force is because of the another property of electron and proton, that is electric charge. So that force is different from gravitational force, is called the electrostatic force. So just like mass is responsible for gravitational force, so charge is responsible for electrostatic force. So the basic and minimum amount of charge comes out to be a charge of an electron, that is 1.602 into 10 to the power minus 19 coulomb. So this is the basic amount of charge a particle can have. So if any matter is any charge particle, that is any charge particle can be an integral multiple of this amount. So the charge of any charge particle should be an integral multiple of this amount. So we can say that charge is quantized. Why we are saying that the charge is quantized? Because you cannot make this smaller than this. So this is the smallest amount of charge a particle can have. So if a particle have n1 number of electron, so the total charge will be n1 into E, and we see by experiment that the charge between the force between two electrons are a repulsive force, and the force between a proton and an electron is an attractive force. So for the convention we say that proton is positively charged and electron is negatively charged. So this is just a convention, and the amount of charge that contains is same, but the sign is different because the force is the nature of force is different. So we can say, okay, so we are talking about the electric charge. So we have discussed that charge is quantized. So the force between two point charges is given by a basic law of physics, that is Coulomb's law. So Coulomb's law states that the force between two stationary point charges is proportional to, so the force is proportional to directly proportional to the product of two charges and inversely proportional to the distance square of their distances. So we can say by our 10th class mathematics that F is equals to, there is a constant K q1 q2 by r square. So this is the basic form of Coulomb's law, but we have to study it in the vector format. So if we consider 2-point charges, if we consider 2-point charge that are separated by a distance r, this is q1 and this is q2, and there is the separation between these is r vector. So we can say this force between them will be k q1 q2 by r square into r hat. That is the point of direction of this force. It is there. So we are talking about the Coulomb's law. This is a reflection. So the 2-point charges q1 and q2 are there, and the separation between them is the r vector. So the force is k q1 q2 by r square into r hat. So this is k q1 q2 by r square into r vector by r, that is k q1 q2 by rq into r vector. So this is the vector form, very basic vector form of Coulomb's law, and the constant k is experimentally measured, and in SI units it is often written as 9 into 10 to the power 9, 9 into 10 to the power 9 Newton meter square Coulomb minus 2. So this is the constant, and the constant is often written as 1 by 4 pi epsilon naught, where the epsilon naught is the permittivity of free space. So the equation becomes F is equals to 1 by 4 pi epsilon naught q1 q2 by rq to r vector. So this is the format, and there is another format we have to study, that is if we consider the 3-dimension two charges in the 3 dimensions. So this is the origin, so this is the point charge q1 and this is the q2, and the position vector of q1 is r1 and the position vector of q2 is r2. So this should be the third vector, that is the distance. So if we say this is r21 vector, that is r2 minus r1 vector. So here we can say that the force if okay, this is not the reflection is coming, okay, write it here. Okay, f21 vector is 1 by 4 pi epsilon naught q1 q2 by the distance between them is r21, okay, r21 square mod r21 square into r21 vector. Okay, now this is 1 by 4 pi epsilon naught to q1 q2 by this is mod of r2 minus r1 square into r21 okay, this is hat, the direction vector. Okay, so there is some technical problem. So the force, we are saying that the force on q1 force on q1 due to the charge q2, the force on q2 due to the charge q1 is F21 vector is equals to 1 by 4 pi epsilon naught into Q1 Q2 divided by mod R2 minus R1 square into R21 hat. So this is the direction. So if we say that this write it in the vector form, so this is the Q1 Q2 by R2 minus R1 whole cube into R2 minus R1 vector. So this is the force on Q2 due to Q1, and if we write the force on Q1 due to Q2, so we can write that is F12 vector is equals to 1 by 4 pi epsilon naught into Q2 Q1 divided by R12 square into R12 hat. So we can say that this is 1 by 4 by epsilon naught Q2 Q1, and both are same, both are not same. Both are not same. So this is the mod of R1 minus R2 whole cube into R1 minus R2 vector, R1 vector minus R2 vector. So we can say that F21 is equals to minus of vector vector F12. So we can say the Coulomb force is consistent with the Newton's third law, that is the action-reaction force. So there are some important points about the Coulomb's law. The first is that this is strictly applicable to stationary point charge. Okay, so we are talking about the Coulomb's law. Okay, we have discussed about the Coulomb's law. So again, consider a charge capital Q and a test charge small q, and there is some origin O, and this is the position vector of the charge capital Q, and this is R prime vector, position of the test charge. Okay, so the distance between them is capital R. We can say this is R vector minus R prime vector. Okay, so the force from the Coulomb's law, we know that force is equals to F is equals to 1 by 4 pi epsilon naught Q into Q by R square into R hat. We can write it that Q into E, where E is 1 by 4 pi epsilon naught Q by R square into R vector. Okay, so this is the force per unit charge. Actually, this is the force per unit charge at this point. So this is a function of the position vector. With respect to the source charge capital Q, but this is independent of the test charge. So this quantity is called the electric field. So electric field is nothing but a force field, a field that is created by a point charge, and when a test charge comes under the position of this source charge, it feels a force. So we can say the electric field, the space surrounding this source charge, it creates an electric field. Okay, but so the force F, this force on small q due to the capital Q, considered as arising in two steps. The charge Q, this charge set up an electric field around it. Okay, and when a test charge small q is placed without disturbing the position of the source charge, it feels a force. That force is given by the Coulomb's law. Okay, but if the test charge small q is high enough, we cannot define the electric field. So when we are defining this electric field, concept of limit comes, because we consider the test charge as tends to 0. So that the field can be defined as the limiting value of the test charge. Okay, and also we can say that the electric field is also obeys the principle of superposition. If there are discrete amount of discrete values of there are discrete point charges q1 q2 dot the n number of charges, we can say that the total electric field E is equals to E1 plus E2 plus E3 plus dot En. Okay, so the electric field also obeys the principle of superposition. Okay, we will